Boy, does this thing seem like it's straight out of science fiction.
Oh, absolutely. I mean, where do we even begin? It's a four-legged, rideable robot.
A robotic horse, as some are calling it.
Imagine a horse that never eats, never sleeps, and never stops moving. Now power it with hydrogen, replace muscle with metal, and you've got Corio, Kawasaki's wild new robot. This four-legged machine runs on clean fuel and handles rough terrain that would leave wheels stuck. It's not just cool and futuristic, it might completely change the way we travel. But what exactly is it made of, and how does it work? Let's take a closer look at the hydrogen-powered robot horse that's making waves worldwide. They say innovation is just a new take on old ideas, but sometimes something comes along that feels like a whole new chapter. That's what happened in April 2025 at the Osaka Kansai Expo. People were expecting the roar of Kawasaki's latest superbike. Instead, out rolled Corio, a hydrogen-powered four-legged machine you can actually ride. It stands about 1.5 meters tall, roughly chest-high, and its sharp visor and sleek body make it look like it belongs in a sci-fi movie. Inside its sculpted frame is a compact 150-centimeter hydrogen engine. Instead of turning wheels, it powers a generator, which sends electricity to motors in each leg. Early numbers say it puts out around 20 horsepower, enough to climb hills with ease and without a drop of pollution. Each leg has its own motor, so power hits the ground instantly. And the only thing Corio releases into the air? Just water vapor. Even in the heart of a rainforest, it leaves no trace. The real magic is in its legs. Each back leg has a swing arm setup, like the ones used in off-road bikes, letting it move smoothly over uneven ground. Its rubber feet are split down the middle. They spread out on soft sand and grip tight on rocky paths. Meanwhile, onboard vision sensors adjust every step, so Corio moves like a calm, sure-footed mountain goat, not like a noisy machine. Getting on Corio feels surprisingly natural. It has a motorbike-style seat, simple handlebars, and footrests that adjust themselves and fold away when not in use. You don't need a joystick. Just shift your weight or move the bars gently, and Corio responds like it's alive. Pressure sensors in the grips and stirrups pick up even small movements and turn them into commands. The dashboard is clean and simple. It shows your fuel level, posture, and a single arrow pointing forward. That's it. After dark, Corio lights up the trail ahead with soft guidance lights. A subtle glow from underneath makes it look like it's floating just above the ground, adding a touch of wonder without being flashy. Its frame is a mix of carbon fiber and lightweight alloys, finished with Kawasaki's bold electric green highlights. It weighs about 180 kilograms, heavy enough to stay grounded, but still light enough to move quickly and confidently. The power comes from 2 hydrogen canisters mounted at the back, just behind the seat. This keeps the weight centered and the fuel safely away from the rider's legs, a trick borrowed from racing bikes. Corio is part of Kawasaki's bigger vision called the ALEC Mobility family, a lineup of hydrogen-powered machines from walking vehicles to ships. Right now, the prototype can carry about 100 kilograms, go round 150 miles on one tank, and cruise at a steady jog. That's ideal for rescue missions, off-road commutes, or anywhere roads just don't go. An obstacle course. In Kawasaki's concept video, Corio is shown with a possible top speed close to 100 kilometers per hour. But at the Osaka Expo, the real-life version kept things slow and steady, more of a careful walk. Still, it climbed a stack of cinder blocks without spilling the rider's coffee. For now, Corio is just a concept, but it proves something big. When wheels give up, legs and clean hydrogen might be what keeps people moving forward. We've met the horse. Now it's time to meet the heart that powers it. Corio's hydrogen heartbeat. Picture hydrogen as rocket fuel stored in a high-tech, reusable bottle. Corio carries that bottle behind its seat, a tough carbon-wrapped cylinder filled with compressed hydrogen gas. You pop out the empty one by pulling 2 spring pins, slide in a full one, and click it into place. The whole swap takes about as long as strapping on a bike helmet. That means no searching for an outlet. Just switch and go, perfect for rangers or rescue teams in remote areas. Once the new tank is locked in, a tiny 150cc single-cylinder engine hums to life with a soft whir. Kawasaki built this engine to burn hydrogen only, but instead of directly moving the legs, it spins a generator. That generator powers batteries and 4 electric motors, 1 in each thigh. The chemistry is simple and clean. Hydrogen meets oxygen, creates electricity, and leaves behind a little puff of water vapor. No gasoline smell, no carbon, no drama. Just quiet, reliable power. So why hydrogen? Because a tank like this can carry hours of energy and still weigh much less than the giant lithium battery pack you'd need for the same distance. That makes Corio light and agile instead of clunky like a metal rhino. And since gas flows much faster than electricity charges, a refill takes seconds, not half your lunch break. It's that mix, trail-ready and quick to refuel, that lets one robot handle a full day's work without missing a beat. Of course, hydrogen has to reach the trailhead first. Kawasaki's been working on that too. Back in 2022, their ship Suiso Frontier became the first in the world to carry liquefied hydrogen across an ocean, bringing it from Australia to Kobe. That trip showed it was possible and safe to deliver hydrogen in large amounts. Think of it like a massive thermos, supercooled to minus 253 degrees Celsius, rolling into port with enough clean energy to power a whole fleet of Corios. There are still questions about where the hydrogen comes from. Early supplies were made using coal or natural gas, which raised concerns. But Japan's energy planners, and Kawasaki with them, have started shifting toward cleaner options. Today, small plants using wind and mountain hydro are producing green hydrogen using electrolysis. As those scale up, Corio's overall impact shrinks. Even the fuel it runs on is headed toward being totally carbon-free. Hydrogen might just be the 21st century version of hay, except instead of feeding a horse, it powers one that doesn't get tired, doesn't sweat, and leaves the air cleaner than it found it. Game-changing tech rarely shows up out of nowhere. So let's take a look back at how Kawasaki got here in the first place. Before it made a robot horse that could step over boulders, Kawasaki built robotic arms that could weld cars with pinpoint accuracy. And before that? Warships. A lot has changed since the late 1800s, but one thing stayed the same. Kawasaki loves building machines that move with real purpose. Their robot story started in 1968 when Kawasaki teamed up with Unimation, the American company that built the world's first industrial robot.
Industrial technology is now heralding the age of manless production. Numerous tests are being carried out on Kawasaki Unimate, a multi-purpose industrial robot.
The result was the Kawasaki Unimate 2000, Japan's first homegrown robot for factory work. It was hydraulic and bulky by today's standards, mostly used for welding, but it was the beginning of something big. Japan was serious about automation, and Kawasaki was all in. By the 1980s, robots were getting smarter and more compact. In 1981, Kawasaki introduced its P-Series, their first fully electric robots. Unlike the older hydraulic robots, these new electric models were faster, cleaner, and easier to manage. Just 2 years after that, Kawasaki introduced the E-Series, built specifically for detailed assembly work. Then, in 1989, the J-Series arrived. It had more flexible joints, perfect for tricky tasks like following curved surfaces or fitting into tight welding corners. The 1990s were all about fine-tuning. In 1992, Kawasaki released the UEE series with smoother motion control and much better repeatability. Key for industries like electronics, where even a 1 mm mistake can wreck the whole product. Then came the FS series in 1998, designed for lightning-fast, high-precision picking and placing. A year later, the Z series joined in, tailored for painting and coating, especially in car factories, where an even coat can mean the difference between a glossy showroom look or a dull finish. By the early 2000s, Kawasaki started thinking even bigger. In 2002 alone, it launched the M series, strong enough to lift heavy loads, and the Y series, which could handle rapid packaging and logistics. Around the same time, Kawasaki entered the world of clean room robotics for chip manufacturing. These weren't just safe around people, they worked where people couldn't, like in ultra-sterile labs where even a speck of dust could ruin an entire batch of semiconductors. But the real leap came in 2015 with Doro, a dual-arm robot made to move like a human. It was built to safely share space with people, no fences needed. Doro could pack boxes, turn tiny screws, and fold packaging, all without bumping into coworkers or taking up too much room. It was compact, careful, and, oddly enough, felt polite. Kawasaki didn't stop there. It stepped into the medical field with Hinotori, a surgical robot made for minimally invasive procedures like prostate or digestive system surgeries. Created with Sysmex Corporation, Hinotori officially launched in 2020 as Japan's homegrown answer to the US-made Da Vinci system. With ultra-precise arms and high-def 3D visuals, it was designed to mirror a surgeon's exact hand movements in delicate, hard-to-reach areas. So when Corio stepped onto the stage in 2025, it wasn't a sudden stunt. It was the result of over 50 years of robotics experience, from machines that weld, paint, and pack to ones that operate on people. A four-legged robot that walks, balances, and carries humans? That's not a gimmick. It's just the next step in Kawasaki's long journey forward. But Kawasaki isn't just a robotics powerhouse. It's also behind some of the most iconic motorcycles ever built. Kawasaki's motorcycle legacy. If there's one thing Kawasaki bikes are known for, it's power. Bold, untamed power that still feels fully under control. But that reputation didn't show up overnight. After World War II, Kawasaki, once known for making ships and planes, turned its focus to something smaller and faster: motorcycles. By 1953, they had developed the K1, a 148 cubic centimeter four-stroke engine designed to help get Japan moving again after the war. Just 2 years later, their first full motorcycle, the Meihatsu 125, hit the roads. Kawasaki's goals didn't stay small for long. In 1960, they opened a factory just for motorcycle production. By 1961, they had a nationwide sales network in place. Then came a major turning point. They absorbed Muro Manufacturing, Kawasaki's merger with Japan's oldest motorcycle builder was finalized in 1964, giving them access to a solid line of four-stroke twin engines. The result? The W1650, launched in 1965, Kawasaki's bold reply to British bikes and proof they could compete globally. But it didn't stop there. Speed quickly became Kawasaki's calling card. In 1969, they released the H1 Mach 3, a two-stroke triple that could tear through a quarter mile in just 13 seconds. At the time, the fastest production motorcycle in the world. Then came 1972 and the legendary Z1. A 903 cubic centimeter four-stroke that could hit 200 kilometers per hour. The Z1 didn't just break records, it practically invented the word superbike. Through the 80s, Kawasaki kept turning racetrack tech into real-world performance. In 1981, they introduced the Unitrack single-shock suspension. But in 1984, the GPZ 900R Ninja stole the spotlight with the first mass-produced, liquid-cooled, 16-valve inline-four engine. It also became the first motorcycle to officially break 240 kilometers per hour. Thanks to a starring role in Top Gun, the Ninja became a legend worldwide. The success didn't slow down. In the 1990s, the ZX-11 held the title of world's fastest bike for 6 straight years. The ZX-6R launched in 1995 and dominated the middleweight category. By 2000, the ZX-12R raised the bar again. Then came the ZX-10R in 2004, the versatile Versus in 2006, and the ZX-14, a speed demon from the same year. In 2015, Kawasaki went all in with the Ninja H2R, a supercharged powerhouse that blew past the 300 km/h mark. As tech kept evolving, Kawasaki added cornering ABS in 2018, allowing riders to brake safely even mid-turn. By 2022, they introduced radar-based cruise control that automatically keeps a safe distance from traffic ahead. And now? They're already working on electric Ninjas, hydrogen-powered models, and hybrid sport bikes. From humble beginner bikes to jet-powered monsters, Kawasaki's spent over 70 years proving one thing: if it doesn't thrill you, it's not worth building. Kawasaki's motorcycles have always set the bar. The real question is, can Corio meet that same standard in the robot world? How Corio compares to the rest of the robo-herd? Let's be real. Corio isn't the only robot that walks on legs, but it is the only one built for people to actually ride. Most legged robots today are used to carry tools, serve coffee, or do dance routines that look more like yoga practice. Corio flips the script. It's a clean-powered, rideable machine made to help, carry, and explore. So how does it stack up against the other big names in the robot world? Let's start with the most famous, Boston Dynamics Spot. Spot's a 4-legged robot, about the size of a large dog. It runs on electricity, moves on its own, and handles stairs and rough ground like a champ. But Spot isn't built to carry people. Its payload tops out at around 14 kilograms, just enough for a small backpack. It's great for inspecting power plants, checking pipes, or exploring hazardous areas. You charge it like a laptop, and it runs for about 90 minutes before it needs a break. It's smart and agile, but it's more of a helpful assistant than a rideable robot. Now meet Hyundai's DALE, a robot designed for customer service. DALE doesn't walk at all. It rolls on hidden wheels. It's sleek, friendly, and can recognize faces and gestures. But it's built for indoor use only. It struggles on anything rougher than clean showroom floors. Hyundai designed it to chat, guide visitors, and maybe snap a selfie, not to follow you into the woods. Then there's Yamaha's Motobot is one of the wildest and most interesting robotics projects out there. Motobot is a humanoid robot strapped to a real Yamaha R1 motorcycle, and it rides it at high speeds. The goal? To test just how precise a robot can be in a racing environment. But Motobot doesn't walk. It's bolted to the bike. It doesn't think like a person, and it can't stand on its own legs. It's thrilling, but it's more about pushing limits on the racetrack than solving real-world travel problems. Now compare that to Corio. Corio is built to carry actual people across real terrain for practical missions. It runs on hydrogen, not gas, which means fast refueling, long range, and no pollution. It doesn't roll, it walks. It uses rubber hooves, not tires. It's got a seat for a rider, handlebars to steer, and smart sensors to help it move like an animal over dirt, rock, or rubble. Unlike most robots that rely on remote controls or preset routes, Corio reacts to your body movements. Corio isn't trying to be the fastest. It's not trying to look human or act social. It's trying to be something we've never had before, a rideable, zero-emission machine built to go where bikes and trucks can't. It's a new kind of transport. So while Spot trots, Dally waves, and Motobot races, Corio walks a different path, carrying people into places no robot has ever gone. But before it starts tackling backcountry trails or grabbing headlines, Corio still has a few big challenges to overcome. What's stopping Corio? As impressive as it looks, Corio's not quite ready for the real world. Turning it into something you can actually ride off-road won't be simple. The biggest challenge? Legs. Unlike wheels that just spin, legs have to walk, balance, and adjust constantly. Every time Corio picks up a hoof, dozens of motors and sensors need to react together. If just one part slips up, the whole robot could fall. That kind of coordination makes it tough to maintain, especially far from a repair shop. Then there's the cost. Kawasaki hasn't said what Corio might cost, but it won't be cheap. A hydrogen-powered, AI-driven rideable robot won't exactly be priced like a weekend mountain bike. Until production ramps up, Corio will probably stay in the high-end concept zone, closer to luxury tech than everyday gear. Fueling is another issue. Hydrogen stations are still rare. Outside of research hubs or pilot cities, finding a place to refill Corio could be a real hassle. If it's going to be widely used, the hydrogen network needs to grow, a piece of the puzzle Kawasaki doesn't control. There's also the legal side. Corio isn't a motorcycle, a car, or a drone. So where can you legally ride it? On roads? Trails? Does it need a license? What happens if it causes an accident? These are big questions, and until governments figure them out, Corio might be stuck behind red tape. And let's not forget public perception. Some people will see Corio as cutting edge. Others might just see a strange robot that no one asked for. There'll be folks asking, why not just ride a regular bike? But that's how most breakthrough ideas start. People doubted electric cars. They laughed at drones. Even smartphones were questioned at first. If Corio can clear these hurdles, win over regulators, earn public trust, and become easier to produce and refuel, it could completely change what off-road travel looks like. And one day, we might look back and wonder why anyone ever doubted a robot horse. Corio still has a long road ahead, but so do the challenges it was built to face. And that's why the world might just need a robot horse after all. Why the world needs a robot horse? Imagine a small mountain town just hit by a landslide. Roads are buried under rocks and trees, helicopters can't land, trucks can't move, and every minute counts. This is exactly the kind of situation Kawasaki had in mind when they introduced Corio at the Osaka Kansai Expo. A vehicle designed to go where wheels can't, and to do it without adding to pollution. Why legs? Because they handle terrain that wheels just can't. A four-legged machine can step over rocks, balance while climbing, and settle onto soft ground without sinking in. Tests with other legged robots have shown they can move through debris, over stairs, and across broken ground where wheeled or tracked vehicles get stuck. But mobility isn't the only challenge. Disaster zones and remote areas usually don't have access to power or charging stations. That's where hydrogen makes a big difference. A small fuel cell tank can be refilled in minutes and gives off quiet, zero-emission power for hours. There's no soot, no carbon emissions, just a little water vapor. And hydrogen fits right into Japan's clean energy goals. Kawasaki Heavy Industries is already shipping liquefied hydrogen across oceans and testing it in trains, ships, and motorcycles. Putting that same clean tech into a robot built for rescue or rugged travel connects green energy with real-world utility. The result? A robot that can go from a city street to rocky trails or forest paths without needing to switch systems and without leaving pollution behind. And it's not just for emergencies. A rural doctor could use one to reach remote patients. Park rangers could patrol fragile environments without building roads. Even older adults living far from towns could use Corio to get around safely and independently. Corio isn't just a robot horse. It's a bridge between clean fuel and everyday access, made for the places where regular vehicles can't go. And if that already sounds amazing, wait until you hear what this kind of tech could open up next. how Corio could change everything. Right now, Corio is a robot horse, but what it points to is way bigger than trail rides or rescue missions. Machines like this could reshape the way we build cities, protect nature, and maybe, one day, help us live on other planets. Sounds bold, but it's not science fiction. It's just where clean energy and smart robotics naturally take us, if we let them. Let's start here on Earth. Cities today are designed for wheels. Roads, stoplights, sidewalks, even parking spots. They all exist because vehicles roll. But Corio doesn't roll. It walks. It climbs stairs, steps over curbs, and keeps its balance on narrow trails. Imagine a future version of Corio delivering groceries through a park, guiding someone with limited mobility across a cobbled street, or carrying gear through a car-free neighborhood. Suddenly, our cities could be greener, quieter, and more people-focused, designed around walkability, not traffic lanes. Now take that same idea into the wild. Conservation teams working in rough terrain often rely on loud ATVs or helicopters, tools that are expensive, disruptive, and not great for the habitats they're trying to protect. But a robot like Corio? It's quiet. It leaves no tracks. It doesn't scare animals or churn up the soil. Add some smart sensors and AI, and it could patrol for poachers, follow endangered animals, or plant new growth in reforestation zones where drones can't reach. In this case, the robot isn't replacing nature, it's helping to preserve it. But here's where it gets really interesting: space. NASA, ESA, and companies like SpaceX are already planning long-term human missions to Mars. And before anyone lands, there's work to be done: setting up gear, testing the land, building shelter. And for that, they're already trying out legged robots. In fact, the DARPA-backed Team Cerberus has tested four-legged robots in cave-like environments similar to what you'd find on Mars. These bots don't need smooth paths. They can walk, climb, and adjust to the land. A future version of Corio, powered by hydrogen or even solar fuel, could carry equipment, set up habitats, or explore tricky terrain long before humans arrive. Any astronaut's boots touch Martian soil. It might sound like a scene from the future, but this is how real change happens, quietly, with one new idea at a time. A robot horse might start out as just a cool way to get around, but give it time and it begins to shift the way we think. No more needing perfect roads, no more noisy engines, no more assuming that getting from place to place has to involve tires. What Kawasaki is building here isn't just another machine. It's a whole new way to imagine movement, through cities, through forests, and maybe someday across other planets too. Thanks for watching, and if this kind of tech fascinates you as much as it does us, don't forget to like, share, and subscribe for more. We'll see you in the next video.